He's going to be presenting on stationary LiDAR 3D scanning. This looks very cool.
Can you hear me without a microphone?
Yes.
Yeah, I'd rather not use it if they can hear me. So, I'm Craig Hubble. I work for the LA County Department of Public Works. Been there for 27 years now. Been in Survey 22. We acquired the Leica Scan Station C10 in 2013, and we're still in the learning process, and we're trying to get it implemented into our daily survey routine. Basically, what we did is last Tuesday, I came out here and we scanned the park here just to kind of show you what we got. So this is just the raw data as it was after it was all stitched together. You can see right here, this was my first initial scan, and that point is X, Y, and Z all set to 0, which is the center of the scan head. So then as you go through and do the scans, we did I think 8 scans. We started here. Here's the stage. We did a scan here, scan on this corner here, one in the middle, one here. Came back and scanned this stage area, and then did a high definition scan of George Washington. We'll show you that. This is the scan that's been colorized. The raw data comes in and looks like this. And this has not been cleaned up. If we go here to kind of to the stage area, zoom in, come around. I don't know if you saw earlier this morning, there was some people doing some exercises out over here. It's kind of hard to see in this view, but out here we've got people doing their morning stretches at about 9 o'clock, 9:30. Kind of hard to see. So once we clean up the raw data, you can move on to modeling the data. So in this view, I've cut it down considerably. From this view.
Craig, can I back up a second?
Sure.
How many stations do you need to scan from
So,
to get an image to get to be enough data?
Well, we could have just done one in the middle of the park here, and it does the scanner does 360 by 270 this way. It can't get, when the scan head comes down, it obviously can't pick up right here. So you got about a 6-foot circle where you don't get any data. So it'll do 360 by 270, and it'll go out. Well, that's the Clara Shortridge courthouse across the street right there. It picked that up, but it's not going to be as good a data as the surrounding information right down here. You don't want to use the data that's out that far. We'll typically do a scan, and then our next station will set up 300 feet away. So we have 150 foot of overlap. And we'll try to cut out that data that goes beyond that. And we found that out in doing the scan of Pacoima Dam. We were 500-600 feet away from the dam face, and the scanner picked up some stuff on the dam face, but as we got closer, when you turned that and looked at it, it was fuzzy. The data from 500-600 feet away wasn't nearly as tight as closer. So there's some quality control issues, and it's a learning curve on our part to take care of that. So this is the raw scan. It's just been stitched together, and everything's on X, Y, and Z 0 based on the initial location of the scan. to put it on a coordinate basis. You basically do a target acquisition, and you can do that target acquisition when you're doing your initial scans, and you don't have to have coordinates at the time you do this. You can come back 6 months later and put coordinates on them. You come back the next day, whenever you want to do that, and then you just re-register. You have this one registered, and you bring in the coordinates and register it again, and now you're on your actual coordinate base. So if you don't have time when you do the initial one, you can do it later. Typically we'll go out and do the scan real quick, and then we'll set our control points and have one of the other survey crews that are out there doing a conventional survey. We'll ask them to get our points that we set up for the scanner and coordinate them, and then when they get that stuff adjusted, they'll send it back to us.
So are you saying, Craig, that you let your scanner reset itself in on your targets?
Say again?
You're saying you're letting your scanner reset itself off your initial
No.
targets?
We'll just use the targets. We'll scan the targets just to get it on the coordinate base. It's all a visual registration now. When I've only been with this program and the scanner since 2013. In the beginning, it was a little more difficult. And now you bring in two scans. One is stationary, the other one you can rotate and bring it in. So you line them up vertically, and then you look at it horizontally, and you lower it down, and then it'll do an adjustment and bring everything together. So Arnold is doing a real quick high def scanner, just an area right there, just to kind of show you what it looks like. The typical scan we do is, and this is medium resolution. To do a 360 scan by 270, it takes 7 minutes, and then afterwards it'll do the same thing as set of photographs. And to do that 360 set of photographs takes another 7 minutes. So you got 15 minutes of data acquisition and target acquisition, or photo acquisition, and then typically we'll have 4 targets. They didn't have any, and we didn't bring any tape, but I thought they had some here. But you can use different kinds of targets. There's a reflective target that's on a pole that has a fixed height. When we did the dams, we ended up taking these, something like this, up all over the dam, just wrote a number on it, and then we were able to set up later and just reflectorlessly shoot to the center of that and get an XYZ and use that to constrain the data.
So what does that make sense? That refines your accuracy that you target?
Well, it just put us on the right X, Y, and Z. Otherwise, it's just floating. Like the scan that we have of this that's right here. If I click on a point, we're going to get a coordinate value down here in the corner. I don't know if you see right here, minus 4.7. 178 and a 21. Well, that's not. That's just based on when the scan hit was sitting over there.
When you do your preliminary work, do you GPS those locations?
So it depends on the project, the scope of the project, but yeah, we'll go out and do GPS coordinates, and sometimes we'll have. This is Arnold. He's our Survey Tech 2, and he runs the instrument for me out in the field. So typically it's Arnold and a Survey Tech 1. So Arnold will have this set up. The Tech 1 will set up the targeting, and then if time permits, he'll have a GPS unit, a triple GPS unit, hooked up to CalVRS, and we'll get real-time coordinates based on that. And then we'll come into the office and put it all together. Currently, we're doing a landslide in Malibu on Marquette. We're monitoring it. They're monitoring the road conventionally, and after every big rain, we're going to go out and do a scan, and we can build a digital terrain model and look at the two. So after I get the constraints down to kind of more of what we wanted to deal with, and this is kind of rough. So this is a stage we're on here, and then we did some 3D modeling on the handrail. We got the light pole right here. Started to do our bench that's sitting right over here. Got some of the pipe work done on that. You could model everything, and then when you're done, you've got a three-dimensional model. That I've not had we're still trying to implement this in the field, and so we have these large data sets. Like I said, the instrument collects 50,000 data points a second, and this is an older model. The new model collects 1 million data points a second. So you're dealing with very large data sets. Just this project right here. Just this little bit here, you're looking at 3 gigabytes of data. So then I took this and I refined it even more. And we have a digital terrain model. Now I went through and cut out the trees as best I could, just not spending a ton of time on it. But cut out the trees as best we could. You can see, right here, that's where a chair was sitting. There, chairs were lined up here, the table here. Sit there, cut those things out, and then we generated contours on that. And this contour interval is because it's so flat here. It's a 3-inch contour.
How much faster is laser scanning compared to do that same thing with regular?
So we got here about 8:30. Started scanning at 9 o'clock. Doing those 8 scans, we were done by 11. Back at our office at Longman Yard, and started on the process of downloading it. And then I spent. That was Tuesday. Wednesday was the holiday, and I did Thursday, Friday putting together this data. Typically, if we were to come out and mind you, this isn't on any control; it's just floating. If we were to come out and do control and topo this, probably a full day of just topo, maybe a day and a half. But for every hour that this runs, it generates 5 to 6 hours of office work. There's a ton of different data sets that you can pull out of this. You wanted to model all these little light standards for the walkway, or the water meters, or there's a ton of information to be pulled out of this. And the nice thing is, you don't have to revisit the site. If we did it conventional, and they for some reason the designer came back and said, well, we really would like to have seen something you didn't get, and we got to come out and revisit the site and survey that portion again if we missed. It's all right here. Like I said, there's different definitions, resolutions. So this is the statue right over there, shot at a high resolution. Let's see, I think this portion here was in the neighborhood of 200,000 or 300,000 data points just for this. And we can get really specific here on. We can measure from George's nose to George's chin. Grab grab a data point here, grab a data point here. So we got about 2200s between those. So you can take good measurements. So we're like I said, we're trying to implement this. We've done about a dozen projects. So after we get the data set, and this is Pacoima Dam above Soma. This project, because we didn't have a lot of experience on data extraction, was sent out to, Dave, was this Somas? So it took us 2 weeks on data collection, I think? Yeah, roughly around there. 2 weeks, and I think it took Somas about 3 or 4 months. Right. So I mean we got a ton of data here, and you know we're able to twist it and look at it here in a 3D CAD environment. So we can take it. So we've done this dam, Santa Anita Dam, Big Dalton Dam, and is that it for now? We've not scanned Tehama yet, but we're water resources likes the product that they're getting, so we're kind of going that way. Also,
why is that product so good? Because it's valve
everything shows up in that, and we like I said, you don't have to go back and revisit to get that data. So just to let me take the view from here. We're going to zoom in down here. So this is looking out that way. Scanner 3. So. It takes a bunch of photos. I think to do the panoramic photo, it's 370 or 270 shots. So here's here we are looking out that way in the model, and here we are looking out that same way with just the photos. And how we get this here is it takes the pixel from the photos that's associated with that data point and applies it to here. Otherwise, the data would look more like this. We have done a couple of litigation surveys, and in that we've done. I've just done a video of this one, but you can do accident scene investigation. This is kind of a flyby animation of the all the surveys put together, or all the scans put together. So what happens is you put together camera points, and then you tell it how many frames you want to generate between those camera points. That's why it's speeding up and slowing down. When the cameras are a little closer together, it slows down. When they're further apart, it's taking that same number of frames to get to the points that are further apart. So there's a lot of different things you can do with it. We've just touched on some of it. And we're trying to implement it within our own division. That's about about all I have. I think on that. We did George. That's scanning.
You do those 3D modeling, like
Yeah.
rails and benches. You have to go through and like do colorization and
So yeah, I
smooth it out.
I could do one real quick. I mean, it's really pretty simple. So let's see, we're right here. Hold on, let's see. Here's another. Right there. So this is going to cut out all the extraneous stuff behind it. So I'm just dealing with the object I want to model. So I can zoom in on this, turn it so I get that. This is another one of those walkway lights. So I'm going to pick a couple points on it. So create object, region grow. It's a cylinder. That's it. We can adjust it down to there, and then just spin it around to pick up some of the top parts to create that dome. And it's that quick. If you needed to get it to, and it's automated. You can, if you were doing the inside of a factory with a bunch of pipes, you can tell it when it's down, when it's importing it, to do a preliminary pipe run, and it'll fit all the pipes together, and then you can go in and edit and make changes as you need. But if I needed to make this cylinder bigger, or smaller, or it didn't quite catch the run because there was a gap, I can move it up. So it can be a very useful tool. We just need to get it
So
going.
is it all your photos that you're taking with it in the background, you're processing, giving your colorization?
It's right there. Yep.
Verification.
Yeah, and I can change the color of this. Go to edit object, edit appearance.
You could just pick the color that the photograph was, right?
But well, this yeah, you can pull it out of the photograph. I think I've not done it, but for sure. So it's a very powerful and useful instrument. And then we have the same thing that is we don't have it. We haven't purchased it, but it goes on a vehicle and it will scan and pick all this stuff up at speed at 35 miles an hour, 20 miles an hour. And it's integrated with GPS, so it's all done. And again, for every hour it operates, you got 5-6 hours of office data extraction time. I think that's all I have on